cup of tea. This time, we're going to define quadratic function. Let us define first function. What is a function? A function is a relation, and a relation is any set of ordered pairs that is x, y. X is the first coordinate, we call that the domain. And y is the second coordinate, we call that range. A function is a relation in which, for each first coordinate, there is exactly one second coordinate, or for every first element x, there corresponds a unique second element y. Samples: first coordinate 1, 2, 3, second 1, 2, 3. 1 corresponds to 1, 2 corresponds to 2, and 3 corresponds to 3. Relation 1 to 1, correspondence. Therefore, that is function. Next is 1, 2, 3, that is the first coordinate. Second, 1 and 2. 1 corresponds to 1, 1 corresponds to 2, and 2 corresponds to 2, 2 corresponds to 3. Relation, many to 1. Correspondence, therefore, that is function. Let's have here another 2. 1, 2, 3. So 2 corresponds to 1, 2 corresponds to 2, and 2 corresponds to 3. Relation, 1 to many. Correspondence. Therefore, that is not function. Try this. Tell whether the following is a function or not a function. Number 1, 2659. Function or not? Definitely, this is not a function because the given is not a set of ordered pairs. Number 2, function or not? Not a function because the given is not a set of ordered pairs. It is a set of pairs of set. Number 3, 5, 3, 7, 5, 2, 1. Function or not? This is a function because the given is the set of ordered pairs. So let us determine the domain 5, 7, 2 and the range 3, 5, 1. Number 4, 4, 5, 3, 6, 4, 2. Is it a function or not? This is not a function, even though it is set of ordered pairs, and yet it is not because we have the same domain, and that is 4. Since you already know the meaning of function, this time we will define quadratic function. So what is quadratic function? A quadratic function is a function that can be written in the form f of x is equal to ax squared plus bx plus c. F of x is also equal to y. So we can also have here y is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The highest exponent of the variable is 2. Hence, it is called a second degree function. And the graph of quadratic function is parabola, or that is U-shaped curve. Try this. Tell whether the following equations is a quadratic function or not. Number 1, f of x is equal to 2x squared minus 7x. Is it quadratic function or not? Yes, this is quadratic function because the highest exponent of x is 2. Number 2, y is equal to x minus 34. Quadratic function or not? This is not quadratic function because the highest exponent of x is 1. Number 3. 10 is equal to x squared minus 7x. Is it quadratic function or not? Definitely, this is not quadratic function. Why? Because it is not in the form of y is equal to ax squared plus bx plus c. Number 4. Y is equal to 5x cubed minus 7 plus 3x. Quadratic function or not? This is not quadratic function because the highest exponent of x is 3. Number 5. Y minus 3x plus 5 is equal to x squared minus 1. Quadratic function or not? Yes, this is quadratic function because the highest exponent of x is 2. Number 6. F of x is equal to the quantity of x plus 3 times the quantity of x plus 4. Is it quadratic function or not? Let's see. Let us multiply. X times x squared. X times 4, that is 4x. 3 times x, that is 3x. And 3 times 4, that is 12. Then let us simplify it. F of x is equal to x squared plus 7x plus 12. So what is the highest exponent of x? 2. Therefore, this is quadratic function. Number 7. Y is equal to 2x minus 4. Is it quadratic function or not? This is not quadratic function because the highest exponent of x is 1. Number 8. 2x squared plus x minus 15. Is it quadratic function or not? Definitely, this is not quadratic function because it is not in the form of y is equal to ax squared plus bx plus c, even though you have here second degree. Number 9. 2x squared plus x is equal to 7 minus y. Quadratic function or not? Yes, this is quadratic function because the highest exponent of x is 2. And last, f of x is equal to x squared minus x plus 8. Quadratic function or not? Yes, this is quadratic function because the highest exponent of x is 2. Let's have here an example on how to determine if the table of values and graph is a quadratic function or not. Let's have here the table. Values of x, 0, 1, 2, 3, 4, 5, 6. Values of y, 0, 1, 4, 9, 16, 25, and 36. Let's have here the first difference of y values. Let us start at the right side. 36 minus 25, that is 11. 25 minus 16, 9. 16 minus 9, that is 7. 9 minus 4, 5. 4 minus 1, 3. And 1 minus 0, that is 1. Let's go to the second difference. 11 minus 9, 2. 9 minus 7, 2. 7 minus 5, that is 2. 5 minus 3, that is 2. And 3 minus 1, that is also 2. You have noticed that the second difference of y values are the same. Always remember that if the second difference are the same, it means this is quadratic function. Let's have here another values of x. -2, -1, 0, 1, 2. Y values, -4, -1, 2, 5, and 8. Let's have here the difference of y values. Let us start at the right side. 8 minus 5, that is 3. 5 minus 2, that is 3. 2 minus -1, that is also 3. And -1 minus -4, that is 3. You have noticed here that in the first difference of y values are already the same. Therefore, it is not quadratic. This is linear function. Let's have the graph. So this is an example of quadratic function. We call it the parabola. Another, this is not an example of quadratic function. This is linear function. And the last, this graph is not quadratic function. It is not also linear function.
Thank you for watching. That's it for this video. If you learned something here, don't forget to like and subscribe to Cup of Teach. See you on the next lesson. Bye!